Hello, this is Coach Meeks, St. Mary's Correctional Center, and I'm going to be working today with my good friend Jamie Oates from Central Regional Jail. As a former geometry teacher at a couple of public high schools here in West Virginia, we decided we're going to start off with a basic unit, a quick little review of some basic geometry terms that may pop up on the TAS test or on some college readiness tests that you may be taking once you complete your high school equivalency to enter a college or postgraduate degree work. Okay. As a teacher, we're obviously not going to go over what's a line, what's a point, a plane. If you have any questions with very basic terms and what they mean in geometry, make sure you get with your teacher, and I'm sure every one of our classrooms has books and other resources that we can cover basic geometry terms. But some concepts to make sure that maybe you understand. Here I put a few common questions that you might be tested your general knowledge on. True or false? Two lines can intersect at more than one point. Well, we need to remember, what is a line? A line is a point and all the points going in both directions forever and ever. Okay. So if I have a line here, sorry, I'm not very good, it's not straight, and I have another line here, and it is where they meet at exactly one point. So can they intersect at more than one point? No, because the only way that I could cross over and do it again would make it a curve, and remember, a line has to be straight. So that would be one to test your knowledge of lines. A line contains more than 2 points, and that would be true. A quick reminder, any 2 points, I can only have, again, one line, go through them. Why couldn't I have another line, go through them? Because, again, it wouldn't be straight. The intersection of 2 planes is a line. What is a plane? A plane is like a flat sheet of paper made up of a line, touching a line, and extending in all directions. Okay? A good place for you to look while you're sitting is just take a look in the room you're sitting right now and look at where your wall meets your ceiling. It doesn't meet at one point, it meets the entire length, which is a line or line segment. So this question would be true. The intersection of 2 planes is a line. One common error that I found in basic geometry is the simple naming of an angle. An angle is 2 rays that share a common vertex or a point, okay? And thus we formed our angle here. And we name an angle, we can name an angle at that vertex, so I could call this angle A. Okay? And the point that is always named with a capital letter in geometry. But then when I go to where we have several angles together, or a figure like this, a common mistake that someone will make will say, is there an angle A? If I go over here and I find A, which angle would I be talking about? Would I be talking about this angle? Or maybe this angle? Or would this angle? Or what about the entire straight line, which is an angle? So anytime that you have more than one angle that can be formed out of the same vertex, remember, we have to name it using 3 points. In other words, an example would be angle CAB. Where I'm starting from, to the vertex, which is always the middle, and then back to your opposite angle. Another angle here could be EAC. And we can keep going on. A common error that a lot of students will sometimes make, and they'll kind of put that up as a sucker question on a test. They'll be meaning something, and they'll have one as one of the answers, angle A, when it's really not what you meant. Okay, probably one of the more higher level questions that are basic that I find quite common, testing our general knowledge of basic terms, is which term is defined. In other words, I'm able to say exactly what it is. And my choice here is point, line, plane, or midpoint. Without going through my entire unit that I would teach you in my basic terms class, the answer is midpoint, D. It is the first term that we normally find that we can totally define. Why? Because a point in geometry is defined as something that's so small that it's not even measurable. So we have to agree that it exists. And then a line is made up of points, And you already heard me say that a plane is a series of lines touching. So what is a plane? Well, it's lines. What are lines? Made up of points. And how do I define a point? Well, we just got to agree. So because of that technicality, the first thing that we normally tend to find in basic terms that we can define is a midpoint. What is a midpoint? Commonly people call it a middle. More technically, it is a point that is exactly the same distance from both ends of a line segment. So it's the point, when we measure, it's the same distance from both ends. A common word we'll see on a test often is they'll use the word bisector. Bi meaning two, and sector means our segment. So I'm going to pass this over to my good friend Jamie Oates of Central Regional, and he's going to describe an example on task where they want us to know what a bisector is.
Thanks, Coach. Now, what is the bisector of a line segment? Okay, and how do I find it? First off, what's a line segment? We're going to go to the next page here. This is our line segment. We've got DMV. All right, as you can see, the entire line segment from endpoint to endpoint is 24. Whether the units are inches, centimeters, it doesn't matter. We're trying to determine our midpoint right here, which is M, the distance between. Okay, we're trying to identify that. So what we're going to do is we're going to take 24. We've got two sections here. We've got section DM, and then we have section MV. Okay, line segment MV. Divide the total length by 2, you end up with 12. So each segment is 12. This is our perfect or midpoint. Okay. Now, as we continue on, we see we have a formula. You're going to see this on the task formula sheet, of course, x1 plus x2 divided by 2, same with y, the y coordinate, y plus y divided by 2. This is our formula. We're going to put that to work right now. Here we have a line segment on a graph, okay? This is the coordinates for point A, the coordinates for point B. As you can see, we come down through here. As we look, we see they have plugged in x for A and B, 1 and 7. Add those together, you get 8 divided by 2 gives you 4. Points Y, 2 and 4. Add those together, you get 6. Then you divide by 2, that gives you 3. So the midpoint lies at 4, 3, which as we see on this graph, 1, 2, 3, 4, and then up 3, that is our midpoint of that line segment, the exact middle. We're going to try a couple now. Here we have received just the coordinates of the two P's, or of the 2 points, P and Q. So we're going to take the X's, 2 plus 4, we're dividing by 2. Then we take the Y points, 5 plus 3, we're dividing those by 2. 2 plus 4, of course 6. 5 plus 3, 8. We get 6 divided by 2 is 3. 8 divided by 2 is 4. These are our coordinates for our midpoint on this line segment. So if we were graphing this line segment, we would come over 3, up 4, and that would be our midpoint for our line segment. And we would do the same thing here with these points as well. Bisector of an angle, bisector of a line segment, the middle of the line segment. That is exactly what the bisector of an angle is. We have a ray that is splitting the angle that we're given in half, okay, into 2 equal parts. As we can see here, we have angle GHJ. All right, the entire measurement of angle GHJ is 52 degrees. All right, then we have our bisector ray HK that is splitting this angle. Okay, so what we would do is we would take 52. We have 2 equal halves we're trying to determine the measure of. 52 divided by 2 is 26. All right, so the measure of each angle, this is how we write our angle GHK equals 26 degrees. And the measure of KHJ is also 26 degrees. Over here we see this marking here means that this angle, the outer angle, measures 90 degrees. So the measure of angle GHJ HJ equals 90 degrees. So we're trying to determine the bisector, ray HK. So we're going to take our 90 degrees, divide by 2, each angle which would measure 45 degrees. Okay. Now we see some symbols up here. Ray BD bisects angle ABC. Now look, ABC, we have our measurements. For the angle CBD, it's 55 degrees. ABD, we're assuming, based on what we know, should be equal to 55. So we're trying to find the value of X. We're ramping it up just a little bit here, folks. So what we're going to do, put this into equation form. All right, now we've got X plus 12 equals 55. If this is a bisector, this ray BD, then 55 should be equal to this. We just have to figure out what X equals. So I'm going to separate everything from my X or my variable. I'm going to subtract 12 from this side. I have the equal sign right here. So I have to be equal on both sides. Got to be fair. These cancel out, which leaves me with the variable X, or the letter X on this side. 55 minus 12 is going to be 43. So if I plug 43 into X, I get 43 plus 12, and it does in fact equal 55 degrees. Same thing over here. Angle ABD is 9x. Angle DBC, 8x plus 3. Now, over here we had a variable on just one side. Okay? Now we have a variable on both sides of the equal sign. So what I want to do is get these variables along with this number or coefficient, get them to the same side so I can determine what X is. 9 minus 8 equals 1x or X. I'm left with a positive 3 over here, so X equals 3. So if I plug 3 into each portion, 9 times 3 is 27. 8 times 3 is 24. Plus 3, both of these angles measure 27 degrees. Now we're going to take it up to the next level, and Coach Meeks is going to come back in here and share a little bit more geometry information with us.
Jamie, thank you very much. Now I wanted to continue on looking at basic angle relationships. Okay. One thing before we move on, many of us know what we're going to talk about, but just a quick reminder, the degree measurement going all the way around the circle is 360 degrees. If you notice, a straight line will cut a circle in half. So then we would know, right, if we picked a point and went on ever and ever in both directions, that a straight line, which is a line, it's also an angle, and it is 180 degrees. Just a key topic that I want to make sure that we don't want to assume. When we start going on to angle relationships, if I know that a straight line is 180 degrees, and I have a ray cut off and form two more angles, okay, we come up with one of the first relationships that we want to talk about. All right? So if this is supposed to equal 180 degrees, or this angle, I'll call this one angle 1, and we'll call this one angle 2, I would know mathematically that angle 1 plus angle 2 will have to equal 180 degrees because we know that that measurement is 180 degrees as we just talked about. And in this situation, if this side is 150, then we would know that this angle over here would be 30. Two angles in a relation that together, in other words, their shared side, their non-shared side, they're sharing this side, their non-shared side, if their non-shared side forms a straight line, then they are called a linear pair. Do you really need to remember that? I don't think so, but just in case, I don't want you to be caught off. That is a pair of angles that form a line. Real simply, side by side, they're going to add up to equal 180 degrees. All right, so that's one of the first angle relationships. Excuse me. All right, and now building on another concept for our next relationship. I know this seems simple, but we're going to talk about it. If I had 80, say $80, plus $30, wouldn't it be true that it was equal to $30 plus $80? So if these two equations are true or set, okay, if I subtracted the same amount or the same thing, I subtracted 30, the same thing from each side. If they're originally equal and I subtract the same thing from both sides, they're going to remain equal. Well, Coach, where does that come into? Well, we're going to investigate our next relationship. All right. I'm going to make the statement that angle 1 here and angle 2 equal 180 degrees. And let's take a look. I have two angles side by side. Their non-shared side formed a straight line. That's a linear pair, so we know it must equal 180 degrees. Here, my next statement I'm going to make is that angle 2, I'll change colors, angle 2 and angle 3 equal 180 degrees. And let's look at them. Their non-shared side forms a straight line, so it must be 180 degrees. So just like we did in the last problem, what happens if we subtract angle 2 from both sides? 180 degrees minus angle 2 gave us angle 1. 180 degrees minus angle 2 also gave us angle 3. So yes, angle 1 must be equal to angle 3. We call this vertical angles. And simply this, if you notice, when two lines intersect and form the four angles, we have proven that the angles straight across from each other formed by the two lines are vertical angles. In other words, real simple, they're the same. They are congruent. Okay? So 2 and 4, I don't know what they are in this problem, but whatever they are, they have the same measurement, and angle 1 and 3 have the same measurement. Okay? So I'm going to let Jamie come in and show where the two concepts of angle relationships, linear pairs, and vertical angles apply into some problems you may run into.
Welcome back. Thanks, Coach Meeks. We're going to do some problems here. All right, we're talking linear pairs, all right? Also, we could call these supplementary angles. All right, I'm going to take, based on what we know a straight line equals, I'm going to take 180, and I'm going to subtract this 151. All right, that is going to leave me with a grand total of 29. Okay, so 29 degrees is the measure of this angle 2 right here. Very simple, okay? Both of these angles here come together to form a straight line, linear pair. Moving on, now, we also talked, and we're going to talk about vertical angles. Okay, Coach may share with us what vertical angles are. We know that they're angles that are opposite of each other. We have this line intersecting this line. So, very simply, all I have to look at this angle here, 154 degrees, which tells me that the vertical angle, or the angle opposite of it, is indeed equal to that. All right, this next problem. Now it says find measures of angle 1, measure of angle 2, and measure of angle 3. Well, I'm going to do the easiest part first, obviously, okay? I know that these two lines intersecting form vertical angles. So I know automatically if this side is 35 degrees, the measure of angle 2 is 35 degrees as well. Now, based on what we know about linear pairs, supplementary angles, okay? Measure of angle 1. So I know that these two angles here form a straight line. So I'm going to take this 180, which is a measure of a straight angle or straight line. I'm going to subtract 35 because this is the known angle. Subtract that, and I get 145 degrees. So that's the measure of angle 1. Now, based on what I know about vertical angles, that's also the measure of angle 3. So very quickly able to find the measure of both angles 1 and 3. Now we're going to step into a little bit the next level of algebra here. So now we have vertical angles, of course. We're trying to determine if this side is indeed equal to this side. We know that they should be vertical angles. So 3y plus 2 is going to equal 104. Okay, I'm going to isolate the variable, get the letter by itself. So first I need to subtract 2 from both sides. These cancel out, leaves me with 3y equals 104. 102, 102. I'm going to get rid of this coefficient. It's multiplied to the variable, so I'm going to divide both sides by 3. 3 divided by 3 gives you 1, cancels out, leaves me with y, and 102 divided by 3 equals 34. So we would plug 34 in here, and we find out that it does indeed equal 104 degrees. Same thing with this, but notice we have a variable in each side. All right, much like a problem we did earlier. I'm going to do 10x vertical angles equals 8x plus 24. Now I've got a variable on both sides. I need the variable on one side, the letter on one side. So I'm going to subtract 8x from both sides. Okay, we'll slide on down here with the rest of this. 10 minus 8 is 2, so that leaves me 2x. That equals 24, because these cancel out. So I'm going to divide by 2. X equals 12. Plug this in. I will find out that 10 times 12 is 120. 8 times 12 is 96. Add the 24. It is also equal to 120. Both sides match up perfectly. Now, we have Coach Meeks who's going to step in and work this a little bit more complex problem.
Here's an example. I will look at this and say, oh my goodness, and there's several ways we can look at this. I've had some students, obviously we can jump in and say, hey coach, here's 2 lines that cross. And so vertical angle straight across, if this is 56 degrees, and this is 56 degrees, you can find that angle. And coach, I got this line crossing this one, so straight across is 28 and 28. But what about this one, coach? Well, just remember, a straight line is still 180 degrees. So I can sit there and say, okay, 180 minus the ones I know, and 28 and 54 is, what do we got? 84? 84 degrees. So these two together are 84 degrees. Now if I subtract them away, I'll find 96. And so this is 96 degrees, and now I have 96 degrees. And the questions they asked me was, what is the measure of angle KPL? Going back to what we talked about earlier, make sure you start at point K, K, P to L would be 96. JPO, J, P to O, we found was 56. MPN, M to P to N, we found was 28 degrees with vertical angles. And last but not least, O, P, N, and it again was 96 degrees. So when it started off looking difficult, remember, things don't change. Remember, the basic definitions didn't change. Your linear pairs, a straight line was 180, vertical angles. These are some basic knowledge, something that looks very complex. If you take your steps to break it down, you can work it out. I once heard a good teacher say, when you look at an elephant, you're not going to, and you have to eat it, just remember, just starts one little bite at a time. Okay, we've taken a look at some angle relationships, and now we're going to move on, looking at some basic line relationships. All right, continuing on, I mentioned that we're going to start in the line relationship. We covered basic angle relationships. One of the first definitions we're going to have to talk about. Several of these things you might already know, but I'm one of those coaches that doesn't like to assume. We all know what assume spells. 2 lines are perpendicular lines if they intersect to form a right angle. And of course, from earlier knowledge, we should know that a right angle is 90 degrees. Lines S and T are perpendicular lines. You can write this as S, and you'll see this symbol meaning perpendicular, and T, I just included that. You'll see that in a lot of textbooks or on tests. Another thing you'll also see is they'll put the box in the corner meaning 90 degrees. Okay, so here we're given a few examples. N is perpendicular to M, so if we know that, looking from our prior experience, then we know they form a right angle, so this must be 90 degrees. And we know that two lines that share side that makes a straight line equals 180. So this just proves that this must also be 90 degrees, and then all these would be 90 degrees. So two lines that intersect that are perpendicular form four right angles, not just one, and that would be an example proving that. In this case, H is perpendicular to K. So we know that this is 90. One big thing that students might do is assume, since that looks like it's cut in half, that both these are 45, but we don't have knowledge. What we do know is that they're complementary, that angle 1 and angle 2 added together must equal 90 degrees, and so that's the definition of complementary. Supplementary, as you've heard earlier in the video, is two angles that add up to equal 180. But we'll use this knowledge as we move on. Here's an example. If line S is perpendicular to line T, then what would we know here? Well, if that's 90, X would also have to equal 90 degrees. Okay? And here, if S is perpendicular to T, we know it forms a 90, and here's an example where the rays cutting, forming complementary angles, and we do have some knowledge. So I know that 40 plus this quantity, 3x plus 5, must equal 90 degrees, and 40 plus 5 is 45, plus 3x, 90. Now I'm going to start isolating the variables. So I subtract 45 from both sides. What I do to one side to move it, I have to do the other. So 3x equals 45, and the opposite of multiplying is to divide, to separate this. What I do to one side, I do to the other, and x would equal 15. Okay. Another angle relationship, another line relationship is two lines are parallel lines if they lie in the same plane and they do not intersect. Okay. And here's an example how you may see it written. Line R and S are parallel lines. Okay. You can write this as R parallel S if you see that in the test. That symbol, you know, they're telling you the lines are parallel. Triangles on the lines going in the same direction are also used. Notice they're not the arrows at the end, but triangles. You'll see that a lot of times in a test, okay? And that's just letting you know different ways to tell you that those lines are parallel. Well, how does that affect? Okay? One very common problem that you'll always see is they'll give you two parallel lines, and then we're cutting this with another line, and they label that T, and in geometry it's called transversal. Not a name you have to remember, but just thought I'd share, you know, the terminology with you. Well, how does that affect us? Well, if you've already worked with linear equations, then when you understand the idea of a slope, that a line never changes, it's straight. So if I'm going at this slope, or rise over run, at this part of the line, it's going to continue on at the same change continuously. So if these two lines never touch, okay, then they'll have the same slope, because if they were changing at any difference at all, they would eventually run into each other. So if these have the same slope, and they're cut by, both of them are cut by a line that never changes, then although I may not know the angles, I do know when it cuts it, that this angle is going to cut, right? And when it comes on down here, it's going to cut the same angle the same way. So 1 and 5 we would know would be congruent, okay? 3 and 7 would be cut the same, would be congruent. 2, and the degree measurement's already marked, would be the same, and 4 and 8. That's called corresponding angles. I'm not concerned with you learning all the names, but if you see here the terms corresponding angles, alternate interior, alternate exterior, okay, and same side interior, just be aware that there are relationships that these names are given, or these angles are given. But the key I want to show you is this. A neat little trick is, this only happens if the lines are parallel. So you have to know that. If the lines are parallel and cut, then I can start, I know these are the same, and we know those are the same because of what? Vertical angles, all right? And I would know these are the same, okay? And I'll use a different color, since I want to isolate the 120 degrees. I know these are the same because of vertical angles, what we talked about earlier in the video. And these are the same, but because that slope never changes, okay, we can cut across, and I didn't do a very good job. I wanted to show you a Z, so let's try to make that look a little bit better. And you notice it kind of makes a Z, and this kind of makes a Z, and that's the little trick I teach my students. Draw your little lines and make your Z, and then you know all these are the same measurement, and all these are the same measurement, and that's the key to helping us finish. So if I follow a line, I know that vertical angles, that's 120 degrees, and now I come up here across, following my Z, so this is 120 degrees, and this is 120 degrees, and now we know linear pair from earlier, 120, so this must be 60, and now we can follow along, and this is 60, okay, and then this is 60, and this is 60, and you notice the same side on the inside still adds up to equal 180, okay, 180, and you'll see all your linear pairs, okay. So just a quick little trick, form the Z's. You can only do this if those lines are parallel. All right, so our newfound knowledge, quickly, let's work some problems. They want us to find angles 1, 6, 5, and 3. I'm just going to show you all of them over here, okay. So if I know, here's the one I know, vertical angles, so this is going to be 50, right? But let's make our little trick. Those look the same shape, and there's our Z, so we can start carrying 50. Well, Coach, are you sure you can do that? Yes, why? Because there's my symbols for parallel lines, and that's the only time that I can use this trick. All right, so if this is 50, then my linear pair would be, this angle would be 130, and now I can do the same trick, make my Z, and there's 130. Okay, and this lower one down here is 130 and 130, and I'm not going to waste time, but you can put the answers in, angle 1, okay, angle 6, and so forth. All right, let's take a look here. All right, I know here's my parallel, so I got a transversal. They just switched it around a little bit for us. Okay, so parallel lines cut by my transversal. So there's the angle I know, so I'm going to make my Z. So these are all 91. Okay, these are all 91 degrees. But they're asking me to find X. Okay, so that means 91 and what? That's right, 89. Okay, adds 180, so my linear pair, and now I can start my Z across, and all these would be what? 89. So X would be 89 degrees. All right, hopefully we can get practice. Here we go. There's the 118 I know. There's my parallel lines, so we can sit there, make our Z. And so if this is 118, yes, that follows. We know that's 118. Okay, again, there's the 115 I know. Similar shape, make my Z. And so now I can say 115. Well, they give us a little bit of algebra, and they say this is X equals 30. And so to isolate the variable, I just add 30 to both sides. We know X equals 145 in that problem. And finally, again, here's my Z. So all these are 145, and I can say 145 equals 4x minus 15, putting a little bit of algebra at us. Okay, so I'm going to isolate the variable. How do I get rid of positive 15? I do the opposite, or negative 15, I do the opposite. So that'll cancel. So that's 160 equals 4x. And the opposite of multiplying the x by 4, I'll divide it to cancel. And x equals 40. All right, so there's an example of how our newfound knowledge with line relationships will come into play. Okay? The last point I want to tie this in, teaching kind of across other parts of math where you might be questioned. If you haven't done linear equations, then you definitely want to go to the algebra section and look up the different videos on linear equations. What is a linear equation? It is an equation or problem that defines a line. In other words, here's one linear equation this is in slope-intercept form. Again, not key if you haven't done it. If you've already done it, hopefully you should know. But here's an equation of a line, and it basically says that here, any x and y, where do my x and y's come from? Well, every point has an x and y to find the coordinate. So every point on that line, if I plug in the x and I plug in the y and do the math in that equation, they will equal. That's simply what a linear equation defines where that line is going. Okay? Well, how does that affect us in line relationships? Well, if two lines are parallel, we've already mentioned it, they never intersect. So that means their slope has to be the same. They have to be going in the same direction, so they never touch. So here's an example of one equation, y equals negative 4x plus 4. So every point in this line fits into this problem. Here's the other equation, y equals negative 4x minus 3. So every point in this line fits into that equation. What's the key little trick? If they would ask me in a test, hey, here's an equation of a line. What's the slope of another line that's parallel? If you notice, that's where you find slope. And you'll see that they're both the same, confirming what we know, that two lines that are parallel have the same slope. And so in this problem, they were both negative 4. Just a little quick pointer, making sure that we don't not answer a problem on a task test that seems really difficult, but if you just apply basic understanding, it'll help you. Here's one. Here's two lines. I don't want to assume that they're parallel, so how do we find slope? Change in y or changing up over change in x. All right, rise over run. So we can see this goes up 2 and over 2. All right, both in positive slope. So my slope, and you'll see it use the letter n, is 2 over 2, or my slope is 1 in this problem. Now go look at this one, up 2, oops, 1, 2, sorry, over 2. So the slope on the other line is 2 over 2, both positive. So my slope is positive 1. And so just another example, here I proved that both of them had the same slope, so now I can say that they are parallel. Okay. We talked about parallel lines, so I quickly want to show you what happens if they're perpendicular. So I'm going to give you a line. Perpendicular means it's cutting at a 90. So that here's an example of one that's cutting straight in at the 90. So if we look at the slope in this line, the original line, it's up 1 over 1. So I have a slope of 1 over 1, which is positive 1. And now let's look at this slope. And if we notice, it's already going the opposite direction. Okay? So if you notice, we're going right down 1 and over 1. So this one would be, our change would be down 1 and over 1. Or my slope is negative 1. It's going in the opposite direction to me. Okay? And that's the key with perpendicular lines. The little trick, quick on a test, is if two lines are perpendicular, whatever the slope is of the first one, okay, and our first one was positive 1, the other one is flipped, or the exact opposite. So our other line was negative 1. All right, well, coach, what happens if I have a slope of, say, 1/3? Okay, so we need to do the exact opposite. So the first part of it, if this was positive, then I would know the perpendicular line cutting through this line with that slope would have to be negative. Okay? And then I said the opposite. So the opposite of going up 1 and over 3 would be what? Going up 3 and over 1. So you invert the slope if it's in a fraction form. All right? And then 3 divided by 1. So here's an example of two perpendicular lines. The slope of two lines that would be perpendicular. Make it a little bit more clear, let's take a look at the problem. What's our slope? Well, if you learned from the linear equation part of algebra, we'll find it right here, y equals mx slope. So our slope is negative 6. What's our y-intercept? It's out here, so it's positive 3. All right, we can define that line. I'm not going to draw the line, but what I want to know, what line would have a slope that's parallel to this line? So the slope for any line that's parallel would be the same, negative 1/6. What if I needed to know, they ask you what is the slope of a line that's perpendicular to this line? Well, then that's when you have to do the negative inverse. So if this was negative, then we know our slope is going to be positive. And if it's 1/6, we're going to flip it. It's going to become 6/1, which is 6. So a perpendicular line would have a slope of 6. A parallel line would have a slope of 1/6. There, hopefully maybe clears up a little bit line relationships. Okay, I'm going to end up this part of Geometry 1 with an activity for teachers that you can do in your classroom. A great chance to prove that when two lines are parallel. So you can see here, they're having you draw two lines along college line paper. Okay? And then you take a straight edge, doesn't matter what angle, take a straight edge and run it, cut a transversal cutting through both lines, and then give them a protractor and let them measure so they can see that the little trick works, that when these are parallel, transversal cuts them, it lets us prove congruency onto the other line angle, the angles that are formed at the other line. Okay, again, I thank you. We're going to continue on, and this is Geometry 1, so you've seen what topics we covered. Geometry 2, we're going to look at polygons. The first polygon is triangles, so there's some angle relationships that are created with triangles. Remember, Pythagorean's theorem has already been covered. We'll add that in our packet here in geometry. I will cover the distance formula, a real neat trick, simple way to remember, a simple way to teach it. Okay, and then we'll take a quick brief look at surface area and volume. I'm just going to show you from a geometry teacher's standpoint how some of those formulas develop, so that when the students hear that part of the video, it might help them remember which one to pick out. We have other videos on actually doing surface area and volume problems. Okay, and then we'll have a Geometry 3 unit, which will be basic trigonometry, very basic, the stuff that could help them in a task test, and we'll cover some of the circle problems, subintended angles and stuff that you see. So I thank you for your time, and I hope you enjoy our Geometry 1 unit.